everyone, so welcome to my channel. I hope you guys are doing well. Well, I can only hope. I don't know if you are actually doing well or not. So let's start today's lead code problem, and I have created the stream, and I will just quickly check if you're live or not before we start. And once everything is in place, I will start the video. Okay, so this is actually, so those who are new to this channel, so we solve daily lead code challenges, and the attempt here is actually unseen. So this is me first time attempting this question. For today's question, this is not the first time. I just tried attempting it, but due to power cut, that live stream was lost. So I think I lost 10 minutes of the video, but I'll continue in this one. So those who are new to this channel, how we proceed. So we take the problem statement. We first read it, we comprehend it, we form what is the logic of what is being asked in the question first, and then we form our brute force approach. Then we optimize it depending on the constraints, and we just take one call to code it up and we submit it up. We don't optimize it further because time goes crazily wild here. So I will
What
try
is
to the logic of what is being yeah, so I'll try to be concise and I'll try to make one successful submission. The goal of this video is to demonstrate life's problem solving abilities. So without any further ado, I'll switch to my iPad and I will be using my pencil to solve this question. Okay, so as we can see, here's the question. So I'll quickly read the question. The question says maximum average pass ratio. So average pass ratio is some term and we have to find the maximum value of it. So there is a school that has classes of students. Okay, so every school has classes of students. What's special about this? And each class will be having a final exam. Okay, so each class will have their final exam. So let's class 1, class 2, class 3, class 4. All of these will have some final exam. You are given a 2D integer array classes. So I'm given a 2D integer array classes where each entry is pass I and total I. So you know beforehand that in ith class there are total I students, but only this number of students will pass the exam. So this is just the passing number, and this is the total number for each class. We have been given that information. So this is the summary of this is the whatever like this is whatever summary of this particular segment. That we have been given a classes array where we have information about how many students pass and how many total students are there. Now we are also given extra students, which is an integer. There are another extra students which are brilliant students that are guaranteed to pass the exam of any class they are assigned to. You want to assign each of the extra students to a class in a way that it maximizes the average pass ratio across all the classes. So average pass ratio is discussed here. So it is defined across all the classes and we have to put these extra students to maximize that ratio. The pass ratio of class is equal to the number of students of that class that will pass the exam, which is P divided by total number of students. So this is called pass ratio. Average pass ratio is sum of these ratios and we divide it by the number of classes. We have to return the maximum possible average pass ratio after assigning the extra students. So after we assign these extra students to a particular class, what will be the maximum average pass ratio? Okay, so in the first test case, what they do, they put these two extra students to the first class and the average comes out as this and it is considered as the maximum one. So what I had thought earlier in those 10 minutes that I will calculate a delta t. So my bad guys, let me just fix this up. So I will calculate a delta t, which is difference of final pass ratio minus initial pass ratio. Not delta t, let's call it PR, whatever pass ratio it is. So final means what? If we add those extra students to this class, what will be the delta? The one which gives me the maximum delta is the final one, right? So these delta, yeah, these delta, they will, sorry, these deltas will be calculated for each and every class. And so let me just tell you how it is derived, how this delta logic is derived. So what I can show you here is this. So a pass ratio is basically P1 by T1 plus P2 by T2. So this is pass ratio, and average pass ratio is sum of these divided by number of classes. So this is a fixed term, right? So we have to maximize this. What will happen here? Some pass ratio, let's call it PR. PR will change to PR plus delta PR. So if we maximize this delta PR, then this entire value will be maximized. So we are assuming that only one class will, where we will add all the students. So extra students will be added to a single class. In that case, we calculate delta PR for each and every class, and we find the max of it, and whichever class gives you the max value, and then compute this average ratio, and we are done with it. Okay. Yeah, I assume so. Hmm. Okay, so that's the case. Now, how is this delta average calculated? Let me just define that. Why are you zooming out, bro? Let's define it here. So delta of average. So this P by T was initial, right? Final will be definitely more because we are adding good students. So final is P plus E divided by T plus E. So let's calculate the delta, which is P plus E divided by T plus E minus P by T. When I calculate this, this is T multiplied by T plus E. This is PT minus plus ET minus PT minus PE. PT got cancelled. We got here E T minus P and T plus E. So we can quickly do this. So we're calculating the delta here, right? So we're calculating the delta here. So we can write this like this as this. This will become, what will it become? T will be divided here and E will be divided here. So we get 1 minus P by T. Mm, 1 plus whatever, but I think those things doesn't matter. I have to calculate this value, and yeah, that's it. This value we have to find which one is maximum, and that will be our answer. So the value comes like E T minus P, E T minus P divided by P T plus E. Okay, extra students is 4 here. So for this case, we can calculate this term, like we can separate it out. We can, but it's no need. No needed. It is not needed actually. e plus t by e. So we can actually calculate the absolute terms and we can then form this. And we send this to 5 precision, so we will go till 10 precision points. Maybe 8. I'll check that for C++. So my goal is this, that my algorithm says this, that I'll calculate the delta for each and every class by putting e students over there, and the class which has max delta, it will win, and when it wins we kind of use that delta to compute the final average. Okay. So if we go to till 10 decimal places, we will be safe anyway. So I'm ready with the approach. Let's go ahead and code it up. So here, what we do here is this. I just need to search. Sorry guys, my history got exposed, but it was just me applying to random applications. Okay, so what should I do here is this C++ double precision limit. Typically 15 to 17 decimal places of precision. So which is actually fine. So Menti is an exponent. I forgot all this, but yeah. Okay, so I'm fine with double because it is 50. I think 15 places is cool enough. So let me do some changes here. I'll just move this to this part where it belongs. Now let's code it up. So my goal is to find the average. Where do we get the maximum value? And then what we do is basically we add that to the existing value, right? So that's the case. Okay. So, let me think. How can we do that? Max of double will work. Definitely work. Yeah. So start with double, and the moment I get the max, I just need the value. I don't need any kind of, yeah. So I call this mx as minus 1.0. What we will doing here is we will be going in the all classes. For auto x inside classes. Okay, so calculate the integer p, which is x of 0, and then we have integer p, which is again x of 1. Now what we have to do, we have to calculate a particular term, which was, let me write it down, which was e multiplied with t minus p, and then this particular term is divided by t multiplied with t plus e. This is our ideal term, so let's call this e. I'm not going to type extra students each and every time. Okay, so what we will do here is this. So double calc is equal to, first I have to typecast these guys, then I'll do a lot of things here. Let me just tell you what I will do. So this is a double division. Let me just frame it up. So this will be integer. So this is fine. T minus p. And then here what we will do, t multiplied with t multiplied with t, I mean t plus c, and then what we do is this, we multiply this by 1.2. So this will give me double calculation. Mx equals to max of mx comma cap. This way we get the value, right? Mx we get calculated. And then what we do next is we calculate the average, right? So for that, we need this first double numerator, and then we need denominator. Denominator is the number of classes. So numerator is basically initially it is 0. Okay, so I can do this computation over here only, like in the same function I can do this computation. So if I move this particular block, I don't know how they move it in MacBook. Okay, yeah. So this was for that. Now I will just calculate the numerator for the average, which is p by t plus p by t or whatever like that. So num plus equals to p divided by t multiplied with 1.0. This is the numerator. What we do, we just add mx to this numerator. What we return is this. Numerator divided by integer what is this, classes dot size, and then we multiply this by 1.0, and we use to precision, and that is up to 5 decimal places. Okay, so we actually return this here, and finally let me check what is the to precision syntax. This is a set precision. Okay, can I use it as a variable? I'm not sure about that. Let's check this quickly. I don't know what my speed is, but how can we do this? Precision is where set precision is here. So what does it return? I don't know, like how to convert a double. I don't want to use set precision, but you cannot round doubles to two decimal places. Double don't have decimal places. They have binary. Oh, I see. There is a lot of thing which is happening here. So if I return this double, I think we don't need to use this precision at all because that will be already taken care while we use the judge, right? Okay, so here we are. So first case is correct. Second case is wrong. Why is that so? Because there is some distribution happening. Now, how this distribution is controlled, that I can actually not tell you. Because that depends on a lot of factors. So, uh, so what I'm thinking here is that what could possibly go wrong in that case? So they have distributed two students to this class, one student to that class, and like that. Now this particular combination, can it be greedily decided? T by E, P by E, 1 minus P by Q, whatever it is, P by T. Can we decide that greedily, like how much to put in here and how much to put in there? Because as much as we put over there, that number is incremented. So there is some interesting patterns which I'm noticing. So this delta is actually inversely proportional to E. So it gives me 1 plus T by E for a given P and P. 1 plus T by E. 1 plus T by E. If E is 0, in that case, what will happen? This term should vanish. That will vanish for sure. So T by E is there and 1 plus T by E. For this term, I have to actually 1 plus T by E. So if we have to minimize that, so for that, that has to be maximized. So let me go back to my screen and do some thinking part over here. Except, okay. So let me do this, do some thinking part over here. So we got this term, right? We got E T minus P and we got T T plus E. Now, what do we want? We want to maximize this. So what I did was this. I separated this part. What I did was multiplied 1 by 1 plus T by E. Yeah, if we divide E here, so it will come 1 plus T by E. And if we have to maximize this, which means we have to minimize this. And if we have to minimize this, we have to also minimize this. And for minimizing it, we need mode E values, right? So this factor, no, not alone this factor, but there is all of these factors as well. So how can I decide that whether we have to use 1, 2, 3, 4, 5, whatever? Right, how can we decide that? How can we decide the distribution? Really? This is not making sense to me, man. I just want to know that So it is clearly evident that they are doing some kind of distribution over here instead of calculating it all, because it is very unlikely that this could fail, because what we're doing is we're doing a max here calculating. We are calculating things very properly. Mx, we are adding it and we are converting it to integer, and we are converting it to 1.0. And num is what? Num is the num is the sum which we were taking it. Right? 0 says that started, and we added the p divided by t part here, and that is the p by t is there, and delta t we are adding here. So p by t is here, and delta t is what we are adding there. Hmm. Now, what distribution? If you come about distribution to use key, that will really depend on if you want to maximize it. That will really depend on 1 plus t by e. So that will really depend upon yeah. So I'm clueless about this because if I think of brute force ways, so this can go up to 10 to the power 5. I think that's what extra student are here. This 10 to the power 5, this 10 to the power 5 will be distributed. If it is distributed across classes, in that case, what will happen? If it is distributed across class 1, class 2, and class 3, if it is distributed, it is not. Okay, if it is distributed, what will happen in that case? We will add those deltas. Correct, we will. So guys, this is really crazy. I don't know how to solve this. Let me think, how can we optimize it further? So if I come to a greedy approach, so let's first cross check if it is incorrect or not. X0, X1 is actually correct. Then we have this part. What we are doing here is this we are calculating, which is E multiplied with T minus P, and I think it is correct, divided by T multiplied with T plus, correct, multiplied with 1.0. Then we take max, which is, we started with -1, so calc will definitely be an edge to this part. Max is mx is this. Now plus equals to p divided by t. Hmm. I don't know, I have no idea what is going on here. Maybe precision values. I need to check the hints. Oh shit, this is the beauty. Okay, so they're saying that just add one student, because if we add more, it will decrease that, right? It will decrease that value. Because if we add more students, this particular value will decrease, decrease, then it will increase. Wait, my analysis is not correct, but it is not correct. But we have to sort it then. We have to sort it by that, and then we multiply it with that. Mhm. This is really hard, man. I don't know. This is not a medium problem, by the way. Because I'm really not sure what is this, by the way. This is a really complex problem, man. Okay, I'm getting sleepiness now. So yeah, guys, I could not solve this problem, and I have taken the hints. So the change becomes smaller if we add more numbers. But that's not the truth. E divided by t plus e is actually e plus t minus t, check, which is 1 minus, yeah, 1 minus 1 minus t divided by t plus e. So as e increases, this value will decrease. Yeah, e by t plus e. So it comes out as e plus t minus t divided by t plus e, 1 minus t divided by t plus e. So this is giving me some sort of feeling here, is that as e increases, this particular term will decrease, and this particular term will increase. Right. Really crazy, man. Really crazy. I will look at this problem later this day. But again, I'm